Hi there, this is Dr. Embody to talk about Project 4. And what we're going to do is look at incomes in the United States and their distribution. You'll often hear a lot of debate about income inequality, the 1%, and things like that. So it's kind of fun to look at some numbers and see how this all plays out. You get things like how rich is President Trump compared to other people? What category has the most people in it, and things like that. In fact, it turns out that one of the things we're going to do is plot some values. It doesn't make any sense for us to plot all the values because the plot is like so skewed in terms of cumulative income. There's so much income at the top end that it's just a flat line, and you can't even see everybody else in it. So we've got some real data here, and let's play around with it. And we're going to ask some questions like, such as, okay, where do 90% of the people fall? Under what income? Or here's an income. So I might say, so there's one question is, give me a percent, tell me what the income is. So 90% of the people, where do 90% of the people fall? Are they making $50,000? Everybody less than $50,000, or is that everybody less than $100,000? Where is it? Or if I pick some value, $70,000, what percentage of people fall under that amount? So those are the two questions we're going to ask, and then at the same time, we'll calculate the average and median income over all the people, and we'll plot. The plot I actually give you, you just have to set up the plot. All right, so let's take a look at this, and we're going to we've got three different data files. One is the 2014, and that's what I give you a number of test cases on. And then there's also the 2015. That's actually the latest one. They haven't created the table yet for the 2016 data. And there's also a 2000 year data. And I give you the data source so you can go and check these values, see if they're see if you find the same ones that I found. All right, so let's take a look at this. Now, there's every line of this file has some, it's arranged by columns. And so we have an income range. There's the bottom of the range, that's column 0. And then there's a hyphen, that's column 1. Column 2 is the top of their income range. So here we're talking about the individuals earning from $5,000 to $9,999. And then how many people are there? Okay, so there's 13 million people who fall in that range. How about the cumulative number? So that means that there are 36 million who are in this range or lower. All right, that's what cumulative means. And then the next column this is a percent. So this value of 36 million, that means 23% of the people in this country are earning less than $10,000. Right? Column 6 is the combined income of all these people. So in this range, 5,000 to 10,000, what they've done is they've taken all those people's income and added it up into here. Okay, and then finally is what's the average? What's the average income of all the people in this category? All right. So we're going to ask some questions on this. So if I had said something like, if I had asked the question, who's, where do 23% of the people fall? Well, they're earning less than $10,000. Okay. That's the kind of questions that we're going to be able to answer. Let's take a look at the data. If you just look at the data file, there's a few things that you'll notice. One is that unlike the previous data file, these are all not so nicely lined up into columns. All right, and so we can't use slicing that we did before. So we're going to use the split, and the result of a split is a list. And so we will get, each line will be converted into a list, and there's column and it's space separated. So the hyphen gets its own column by doing this, and so on. As with many other times before, there's a couple of header columns that we have to worry about. So this is real data. It gets a little messy. And then at the bottom, in the very last column, or the very last row here, we see that there's even an and over. So there's no hyphen, and there's an and over in there. And so this messes things up a little bit. So you gotta watch out for that. And again, real data that complicates things, you'll see that there's commas in there. And so when you read that data in, Python won't handle that very nicely. You're going to have to explicitly get rid of the commas there. And of course, in some numbers, there's a bunch of commas. So there's a lot of messiness there that you're going to have to deal with, and that's what happens when we deal with real numbers. I put the values into a spreadsheet, had to play around with it a little bit in order to get it to fit there. Some of the columns didn't line up perfectly, like particularly at the bottom. And you find things like, all right, how many people are making over $50 million a year? That's 134, not very many. And you can see here the cumulative percentage. Oh, it's up to 100. That's good. And then this column is cumulative in terms of values, and so there's 158 million people who have an income. And the cumulative effect for each one, and then finally the averages in the final column there. So the first thing you have to do is you have to find the average income for everybody in the country. And you can't do that by the last column because these are averages, and mathematically it doesn't make sense to take the average of an average. It's just not a statistically meaningful number. And so what you have to do is you have to take this column, add it up, and then divide by the total number of people, which happens to be that problem. So add these guys up, divide, there's your average. And then similarly, I talk about the where do you find the median? Well, the median is the closest that you can get to 50%. And so you have to look around here and say which value is closest to 50. It's that one, and so the median income is in this range here. And so I define that, but that gets to be a little tricky because you now have to look at these values and decide who's closest to 50. All right. And that's what we had to make up a definition of a median that we could get out of this table because we don't have enough data to find a true median. So that's the median. All right, what else do we do? Well, the other thing we do is we might say ask for a percent, and something like. Where do are 65% of the people? And so we come down here again, we look at the percentage here, the cumulative percentages, and it's in between these two. And so by definition, we take the larger of those two. So we're in this column, we're in this row here. And so, 50% of the people earn $44,000, basically $45,000 or less. Okay. And that, so we have to find the particular value here, which gives me a row, and then find the dollar amounts associated with that. And then the other type of question that we'll ask is to say, all right, pick a dollar value. I'll say $56,000. All right. What percentage is that? So I come down here, 56. 56 fits in this range here. And so that means that we're looking at 78% of the people are earning $56,000 or less. Now, it's off by a little bit because this range actually goes up to 59, but that's okay. That's the best that we can do. And so the response there is 78%. So those are the steps that you go through. Right? First of all, you take a look at the whole table, and you find the average. And then you take a look at the whole table, and you find the median. And then you start looping, and you're asking questions. Given a percent, what's the compensation? Or given a compensation, what percent is it? So what we're really doing when I get down to it, when I'm looping and asking for ranges and percent, I'm given a value and I'm trying to figure out what row am I on. And then once I decide what row I'm on, then I can answer the question. Either I'm given a percent and find a range, or I will do just the opposite. I give you a range and then find the percent. But really what I'm doing is I'm figuring out what row am I on, and then returning the appropriate values out of that. And then, maybe, I could be asking for, the average amount. But anyway, so some value on there. So when you read this file in, what I do is I say, save the information into a data structure. And you get to choose. So for example, you might decide to have a list of lists. And so let's just take a line here, list line 4. What you might do is just take all the data in here and make it into a list where each one of these values is in there. Maybe you'll decide that these guys ought to be together, because logically that's some kind of a range. Or maybe you'll decide to do these as tuples. You get to pick. I don't tell you how to design this data structure, but you'll probably want a list of lists, or maybe a list of tuples. That might be a nice way to go. Tuple of tuples doesn't work so well because you can't grow it very well. And how do you make a list of lists? Well, you create a list, and then you keep appending on. And so you start with an empty list, and you append. And so the way you create it is start empty and keep appending. Okay, so what do I give you to work with? Well, one of the things I give you is a skeleton file. And there are some elements in there that are worth taking a look at. First of all, the plotting. I give you that. You have to have an open file. Hey, guess what? You already have an open file. You can probably copy most of that in here. There'll be a couple of things that will be different. You read the file. So you pass it the file. So you open the file, and then you'll read it, and there you will return your data structure. The data structure that you create. Then you will do things like find the average. So you'll pass the data structure in, and just like I showed you, you have to create an average. Same thing with the median. We have the rules for how to create the median. And then you get into the point where we're asking the questions. So if I provide it with a percent, then we use our data list. Notice how that's what we keep passing in there. Give it a percent, and then we return a value out of that. Or I give it a salary and all my data, and we return a value out of that. Finally, I give you a little bit of the structure of the main. So first of all, you have to determine the year, the average, and the median. So that's the year of the file. And then I ask, do you want to plot? And if it's yes, you go ahead and plot it. And we collect together the lowest 40 values of that particular year, just because. You should try it out, grab all the values and see what the plot looks like. The plot looks like this and then that because of the way the income is skewed. And then you can then you go into this loop where we ask for a range, percent, or nothing. So as long as there is some choice, we will keep going. And so in here, you'll handle the choices, like, if my choice equals R, then I will call my get range. If it equals P, I'll call my get percent, and there'll be a little work there to handle that. So that's the basic idea, and then when you're done with it, then hopefully you can ask some questions, such as, let's take a look here. I give you a lot of information, but you can, first of all, there are some unit tests to actually test each function, and I give you the results of those. So for example, I say oops. If I'm calculating the average and as a check, so if I'm doing the 2014 data, the average should be that. If I'm using the 2014 data, the median should be that. When I do get range here, I've specified exactly what comes out of this. And so we get a range, and then the values out of column 5 and 7. So it's sort of part of the data out of, it's one row of data, not all the data in there. And similarly for the get percent, we have a range, and again, column 5 is the information that we're looking for there. And so those will be those are the values that result when you test the individual functions here, because I'm doing it on the 2014 data. And then the tests on the running of the whole program. This is from the year 2004, and there's the mean and the median, same ones we got up there. Do we want to plot it? No, because Mir can't handle plotting. And then on this first test, I just didn't enter anything there, so it ended. The next test is similar in that, again, I start out with the 2014 data, but now I give a range. You say the percent, 90% of the incomes are below $90,000. And then similar with the percent, we take $100,000 and and I say it's in, oh, well, that's 92% of the people. So 92% of the people in this country earn less than $100,000. Okay. And you can say, okay, so you hear about the 1%. Excuse me. You hear about the 1%. So that would be saying, okay, 99. Let's put in 99%. And so where do 99% of the people fall? Well, you can answer that question now. You don't have to wonder. You can actually use your program to figure that out. The third test has a lot of error checking in it. Suppose I give X's. Suppose I give a value that's out of the range. Suppose I give something that the file doesn't exist. I didn't give you that file. And then we go into the loop, and suppose I gave it an X instead of an R. And then I ask for 104%. Well, no, we only go up to 100%. Suppose it's a negative, and so on. So there's a or a value of negative for income, and so on. So there's a bunch of tests there on error checking. The fourth test is does the year 2000, and I don't actually show you that file, so that just makes that a little more challenging. And then test 5, which only the TAs will have to do that. This one includes the plot. And again, we grab the first 40 income categories, which takes us up to $200,000. If you go all the way out, then the way the plot looks is like this. Because of the concentration of income, it's just not a very interesting plot. That's why I ask for the for the first 40 data points here, just so it's an interesting plot. And then the grading rubric, as we've done before, there's a couple here that there aren't tests for, and and as we've found, we may find that some of these function tests are. I think they're actually going to work nicely this time, but what happens if they don't? Then what really matters are the final ones. But it's not that there isn't some value to the function test, because, for example, on Project 3, there was somebody who passed the test and didn't pass any of the function tests. And they hadn't written any functions. That's why they didn't pass the function test. So end cases like that can work. So have some fun with these numbers. You can play around with them and hopefully answer some questions. And if you didn't appreciate income inequality in this country, then you can see here 130 people with their combined income of something on the order of $11 billion. And if you scroll back and you say, what did the bottom 22 million people, their combined income was merely 4 times that. So you have 130 people combined making as much money as the bottom, say, 10 or 15 million people whose average income, here it is, would go up to $5,000. Okay, and that's the kind of skew that we have in this country. And you can play around with that. And the interesting political question is how do we resolve that? It's not an easy question. But what's nice about what I the way I want you to think, or what one of the goals of this course is that you can actually go and collect this data and then answer questions yourself about, all right, so
Somebody says the income is skewed. Well, what does that mean? Well, let's go look at the data. Now you can look at the data and you can figure that out. All right, good luck with that.